Hello everyone, today I'm going to conduct an experiment to see which of these travel mugs keeps a hot beverage hot the longest. So I'm going to I filled up each of these mugs with the same temperature of water, just to hopefully start the test in a fair manner. So I'll go ahead and take the temperature of each one with this thermometer. Looks like we're at 64 degrees. In that one, we are at 63.7 in that one. And in the final one, we are at 65.5. Okay, so on the right we have an uninsulated Starbucks cup. It's just a plastic cup. We have in the center a YETI Rambler tumbler, and on the left we have a Starbucks ceramic mug. There's a chip in the top, but that shouldn't affect the results at all. And here I have a pot of boiling water that I'm going to use to fill up each of these. So I'm going to go ahead, I'll dump each one of these. And now I'll go ahead and fill up each of these. Prior to doing that, I should have taken the temperature of the water. Just to make sure it's a fair test. Okay, so the water's about 204 degrees Fahrenheit. Okay, I just had to take care of a little spill on the stove. So now we'll go ahead, it's 3:22. I'll go ahead and take the temperature of the liquid inside each of these. We'll call that 188.9. Call this 192.2. This one 180, no, 179.2. Okay, I'll put the lids on and come back in 10 minutes. Okay, I'm back. It's been 10 minutes since the last temperature measurement. So I'll go ahead and open these up and check the temperatures. Okay, 168.5. 6. Okay, 168.5. That one. For the Yeti. $183.4. And finally, the ceramic Starbucks mug. 162 exactly. Okay. I'll see you guys in 10 minutes. Hello, another 10 minutes has gone by, so it's been 20 minutes total with the hot liquid in these cups. So I'm going to go ahead and open these up and take their temperature. Okay, we'll call that 154.5. This one is 180, we'll call it. Okay, we'll call this one 154.6. 154.5. Okay. Alright, see you in another 10 minutes. Alright, it's been another 10 minutes. It's now 3:52, so I'll go ahead and take the temperatures of these beverages once again. Okay, well, at 143.3. This one is 176.8. And finally, this one is 143.5. Okay, see you again in 10 minutes. Okay, it's now been 40 minutes since we started the test. It's 4:02, so I'm going to go ahead and take the temperatures of these beverages. Okay, the ceramic mug's at 134.4, we'll call it. Yeti mug. Is at 173.3, we'll call it. And lastly, the plastic Starbucks cup is at 131.9. Okay, see you in another 10 minutes. Okay, it has now been 50 minutes since we began this experiment. So I'll go ahead and start taking the temperatures. Okay, the plastic Starbucks mug is at 124.7. The YETI mug is at 170.6. And finally, the ceramic Starbucks cup is at 127.9. Okay, see you in another 10 minutes. Hello again. It has been another 10 minutes, so that means this has been 1 hour, full 60 minutes since we began this experiment. This will be the last time that I take the temperatures of these liquids, and then I'll tally up the results and see what we find. So I'll start with the plastic Starbucks cup. Okay, we'll call this 117.9. The YETI mug is at 167.3. And lastly, ceramic Starbucks mug. It's at 125.8. Okay, so I've compiled all of the data for the temperature loss in the 3 mugs, and what I've noticed is that the YETI mug is substantially better at retaining heat compared to the other 2 mug types. So between the initial measurement of the liquid, which was the same for all 3, and the second measurement, which was about a minute after the liquid was poured from the saucepan into the mugs, the Starbucks ceramic mug lost about, well, more than twice the temperature at 25 degrees lost within the first minute compared to the YETI mug, which lost 12 degrees, and the Starbucks plastic mug that lost 15 degrees. And then for the subsequent measurements, the Starbucks plastic mug lost more than the other two mugs on every measurement, with the Starbucks ceramic mug very close behind that, and the Yeti mug kind of in a different playing field. It didn't lose nearly as much as the other two types. So then I've also plotted the information onto this line chart, and what you can see is kind of the dramatic difference. The first three measurements, the Yeti mug kind of has a greater slope, a more steep slope, which means it's losing temperature at a faster rate, and then that rate sort of tapers off and becomes much more steady, kind of a steady temperature loss over time. And by the end of the 60 minutes, the Yeti mug has liquid temperature inside of it 50 degrees higher than the plastic mug and 41 degrees higher than the Starbucks ceramic mug. So I guess the surprising, I guess what surprised me about this data is that the ceramic mug was basically gave the same result as the plastic mug, which I found very surprising, and the Yeti mug. I expected it to be better than both, but not quite as dramatic as this. 50 degrees Fahrenheit higher is pretty substantial over 60 minutes. Okay, thank you all for watching.